Hello. Hello.
I can't wait to see what awesome pet is inside this egg. Do you know the answer? Click here to answer and hatch your own pet on Adapted Mind. Correct. Please hatch your pet. Or answer format.
How was the trip to Nairobi?
I'm going Nairobi to jump.
Yeah, you went to jump.
Yes.
What else did you do?
I'm just jumping onto the kid
You jumped on the.
with my kid.
I saw you running up and down in the mall. Is that true?
No, not fell onto the hole.
Gemini.
The mole eats a worm.
Huh?
The mole eats earthworm.
Hmm? Oh. I won't let you step on me. Hello. How are you? Can you like the live?
Yes.
Hey, asante. Mungu akubariki.
Your food is
I
here.
I don't
Bam.
like to eat the food.
Huyu wangu.
That's not food. That's a
Food
poop.
is here.
No, that's not food. That is a poop.
You will eat or I will steal your phone.
No.
Choose one. Will you eat or I go back or I go with the phone?
Wait, I'm not strong.
Will I take your phone?
Mm. If you refuse to eat, Auntie will take away your phone.
No. No stealing.
Okay, you eat if you don't want me to eat food. Okay?
And me, my food. Thank you for liking and subscribing. Where's my food, Auntie?
Nikulete.
Alafu nikatie avocado. Sio ingine utakula?
Kama itakuwa tamu.
Hebu kata uniletee nusu yangu, weka. Ati kama itakuwa tamu. Wewe kaa. Wewe kaa.
Kuna ingine yenye hata ikwangi tamu kabisa.
Inakuanga majimaji. Lakini mu kula tu. Avocado ni avocado.
Imeshafika, si ndio?
Exactly. Umeona simu yako ama bado?
Sijaiona. Hata sijaanza kutafuta.
Anza kutafuta utaipata tu. Hello all guys. A certain thief decided to character develop me. And that's why I went offline. That's why you have not been seeing my videos. That's why I've not been posting. And guys, guys, please like the video. I see your 5 of you. Can I like the video so that it may be recommended to more and more people? And I'm also waiting for my class to start. Am I searching for continuous time state space estimation?
Just a piece of meat.
Hello, Karen. I'm looking for the assignment. Yeah, this is the assignment. Can you like, subscribe if you haven't? We are coming back this time on full force. We're going to be doing maybe 2 videos every week, maybe 1 for starters. But yeah, we're planning to come back like we never left. Welcome, like, comment, subscribe. Ask me anything you'd like to know also. Let me show you exactly what you're doing. I'm here. Yeah. Waiting for everyone to join us. Also the lecturer to join.
Do it, sis. Do it. Do it.
Until you're not eating your food. Why?
I'm going to steal your phone.
And to steal his phone. Steal it.
I'm going to steal your phone.
Why is he not eating his food? Steal
Okay,
it.
you eat your phone. Will you eat food? I'm going to steal your phone. Bring here.
Somebody who is not eating, his phone should be taken away.
Kwani imefika?
Alichukua mapema.
Wa?
Yaani immediately. Wacha nione kama nimeweka kamera on. Watu wananisikiza kwa darasa wakishangaa shida yake ni gani. Hapana. Wananisikiza.
I'm going to come back to steal your phone, okay? If you don't want to eat, I'm going to steal your phone today. You will sleep without a phone. I'm coming back for you.
Dun, dun, dun. Well,
Yes, good evening. Good evening. Good evening, doctor.
good evening.
People are taking time to join. I don't know what the problem is. Mama wame decide kusikiliza the address. Listening to the president. So we have Peter. Peter, you are with who, Jack? Yes, we are with Peter. Okay, then we have Muna, you are with who? Esther. Esther, then we have Josephine. Josephine, you are with who?
I'm with Rachel.
Josephine.
I'm with Rachel.
So at least now we have quite a number. You have at least half the class. So Peter and Jack, you are the first group. So we can start with you. Okay, Dr. Yeah, allow me to share the screen. I don't know, can you see my screen? Yeah, we can see it.
Mom,
Yes.
Papa's is screen PS.
So my friend Peter and I, we are going to present about first algorithm.
So the first does not mean yes, the answer must remain correct. The improvement comes from better logic, not only after computer. In large data set, all small design change can save thousands or millions of operations. Finality matters. So the importance of algorithm is that a large data set makes true procedure impractical. Secondly, good algorithms reduce waiting time and computing cost. They allow real-time work such as search engine, banking, GPS, and AI. Also, in estimation, they help fit more faster and test more candidate solutions. Next, we have just a minute. We have what is a fund? I think I've repeated myself. Just a minute. Okay. We have a measuring speed and time complexity. So, time complexity
Baba, come with
is
your
how
food.
running time grows when the input size n becomes larger. Big O notation does not measure the exact number of seconds an algorithm takes. Instead, it shows how the running time grows as the amount of data increases. Yes. I don't know whether it's because of your network does not listen. Okay, can you see my screen? Yeah, we can, but your slides are like they are breaking. They are breaking. Yeah, someone cannot read what is the slide.
Yeah, they are a bit blood.
Yeah.
A bit blood. So maybe what you can see, you can do.
Or Jack, I share mine and then I scroll for you. It's okay, no problem. All right. So sharing.
Eunice, welcome to my live.
All right.
I am multitasking. I'm taking supper. I'm studying.
Measuring speed. That is
I'm mothering.
So the main idea here is that time complexity describes how running time grows when the input size n becomes larger. The big O notation does not measure the exact number of seconds an algorithm takes. Instead, it shows how the running time grows as the amount of data increases. For example, maybe in a class of a class has 10 students. Almost any algorithm will seem faster because we have a small number, that is 10 students. But when the data grows to 1 million students, the efficient algorithm becomes essential. So Peter,
I have a cavity, guys.
So
It's doing me injustice.
we are going now to
Jesus
talk
Christ.
about binary search.
Have you finished your food?
Binary search
Have you finished your food because you're coming to disturb?
already be
Go eat your food.
must be already.
Are you bring your mouth? Bring your mouth.
Secondly,
Bring your mouth.
compare the target
Don't call
with
me
the
first. Bring your mouth.
middle value.
Come if you want me
And
to
also
talk to you.
discard the hub
Come.
where the target cannot be
Bring your mouth.
repeat until the target is found.
Come, Baba.
on
Come, I
the
tell you something.
end.
Come, I tell
Maybe
you
you
something.
can maybe imagine
When?
searching for a word
To
in a
carry.
dictionary instead of and checking every word one by one. most people open the dictionary near the middle. This is the same principle used by binary search. Therefore, we can say that binary search is successful because it eliminates half of the remaining possibilities with each step, making it extremely efficient for large data sets. So you can go to the next, that is merge sort. So under merge sort, merge sort follows the principles of solving large problems by breaking it into smaller and simpler problems. For instance, here we have 837,426. We did split this one to small numbers for you to, we sorted it to small numbers. That is 837, and we did place here gap, and the other one we can read it as 426. So we did break it into smaller and simpler problems. So this approach is common in computer science because smaller tasks are usually easier to manage. So one reason merge sort is highly valued in its predictable performance, unlike algorithms that perform differently under various conditions. So merge sort remains consistent and efficient. So I will end my presentation there so that Peter can take over. Thank you.
All right. Thank you, Jack, for that. So I'll take on from example 3. Hope you can see.
Yes, we can, Peter.
All right. So whereby you look at the quick sort. A quick sort is whereby you choose it's like when you are starting, you have a certain array of numbers or certain variables. You just choose a certain value as your threshold. For example, if you have so let's say you want to search or to sort numbers 0 to 10. Then you choose your pivot variable as 5. So you sort for values or numbers less than 5 and then greater than 5. That is, you sort the left and the right. Then later you combine the sorted list. So basically what you're saying is that you choose a pivot value from the list. Then place smaller values on one side and larger values on the other side. Then repeat the same process with process inside each tile. Then the average speed of this the quick sort will be the big O n log of L. So the big O just describes how the running time of an algorithm grows as the amount of data L increases. Whereby the N, that is the small n, is the number of items, and the log N is the number of times you divide the data into half. So therefore, the average speed of the quick sort is the big O log of N. The amount of running multiplied by the number of times you can divide the data into half. But now it grows from the speed grows poorer or becomes poor when the choice, the pivot choice, can lead to O n squared. That is, the number or the amount of data will increase substantially, therefore increasing the amount of time needed to solve. And we come now to further in estimation. So we know the solution often searches for parameter values that best explain.
Betty, thank you very
So therefore,
much.
first algorithm
Can you like the live?
reduce the number of trials needed to reach a good estimate. They are useful in maximum likelihood, least squares, Bayesian computation, and simulation. So the aim of first algorithm estimation is actually with reasonable computation time. So for example, instead of testing every possible value of a parameter, an optimizer moves towards best value test benefit of this is that large models can compare attending acceptable time. We now come to example 4 of first algorithm, that is to lapse parameter estimate by improving a starting guess, and it uses the slope and curvature of the objective function. So in this method, each iteration comes closer to the optimum when the model behaves well, and it's common in predicting this method is to estimate is given by the old estimate. You subtract the slope or the covered. The mean a steep slope means the current and the control of the correction. In dynamic programming, whereby basically what this does is to avoid repeating the work. Many times. So therefore, dynamic programming stores answers that have already been computed. So when the same condition appears again, the stored answer is reused. So therefore, this time then store the answer, and then later use that answer. And this method that is useful in sequence model optimization as we create calculations. So example 5 is the Dijkstra, whereby this algorithm is used to find the shortest path from one starting point to the other in a network. So if it keeps the node distance to short, then the closest and visited node is selected next. And this algorithm, that is the Dijkstra, is used in GPS navigation and network rules. So as you can hear, you move the distance from A to B4, B to D is 5, 1, and then it is 2. So therefore, in this method, you move from A to that is, you take the shortest node distance to each node. So you can see from A to C is the shortest distance. Taking A as starting point is 2. Then from C to D is 1. Then since now you cannot move from A, D to then B to A. So that's how it works. Then what factors we consider when choosing the right algorithm? So you first of all check the data are sorted, unsorted, small, large, or